Graphene is a unique nanoscale form of carbon that is disrupting legacy materials, bringing step-change improvements in performance across a wide range of industrial and consumer applications. From energy storage and electronics to everyday materials, graphene enables products that are better, stronger, and lighter, while increasing durability and improving sustainability. Graphene is leading the era of new advanced materials.
The following is a presentation that was given as part of a two-day virtual Graphene Investors Conference, hosted by the Graphene Council.
Happy to share a little bit more about our company today, Elemental Advanced Materials. Many of you who've known about Elemental have probably known it as Elemental Recycling. We had a rebranding transformation earlier in the year, and so forgive me if I still occasionally say Elemental Recycling instead of Advanced Materials. But we see an awful lot of opportunity in the graphene space. Certainly, it's a statistic Terrence talks about quite a bit, but we see graphene demand growing at a 36% CAGR. Another thing with the Elemental technologies, we also produce hydrogen through our process, and I'll talk about that as well. But in addition to producing ultra high purity graphene, we also produce very sustainably produced low cost hydrogen as well. Next slide, please. We're a great solution. Our process enables the ability to unlock high quality, low cost graphene at scale in a way never imagined before, in a single step continuous process at CO2e neutral. Next step, please. Again, we've got a pretty large patent portfolio with over 13 domestic and international patents. In addition to producing graphene, we also produce carbon nanoonions, which are a higher level carbon nanomaterial. Obviously, hydrogen as well, but some interesting things about us: over 99% purity of our product. We have the ability to quickly scale for production for commercial use. And we're building on existing technology. What we've been able to do is take existing off-the-shelf technology that's been proven in other areas, retask it for our specific use, and put it into scalable production. Some things that will set Elemental's tech apart. One, graphene is ready to use without additional functionalization. We are CO2e neutral and have a path towards being CO2e negative. And I'll speak about that later. Our process is single step. It is continuous, and in a fraction of a second, go from waste plastics, which we use as feedstock, into ultra high purity graphene and hydrogen. Regardless of feedstock, we're able to produce consistently at scale. So whether we're using HDPE, LDPE, polypropylene, PVC, PVDC as a feedstock, we can produce consistent quality on the graphene side. And then our process and our product our equipment rather is actually pretty modular. So we can pick it up, deploy, and really be anywhere we need to be to produce high purity graphene. The company has been formalized since 2019, but the founders first started working on this in the 2010s. The company was established again in 2019. We had our first pioneer scale. We went from bench scale in the 10s to pioneer scale in 2019. In 2022, we placed an order for our first commercial unit, which was then delivered late 23. And we're currently in final commissioning stage of our first commercial unit, which is about the size of a Chevy Suburban or Sprinter van, and takes in-feed capacities of up to 10 to 12 tons of waste plastic per day, and converts that into graphene and hydrogen. Again, our products, we make turbostratic graphene, which is a multi-layer graphene that's slightly offset, which we've seen gives really great performance characteristics, whether being used in battery applications and plastics and coatings, or even in things like concrete and asphalt. In addition to that, we also manufacture carbon nanoonions, which are derived from waste gases that we were able to put through our process as well. And these are individual buckyballs of carbon that are held together with fullerenes. I'm happy to speak about that if there are more questions. And then last but not least, very low cost, high purity hydrogen as well from our process. A little bit about our commercial developments. We have over 50 NDAs with potential offtake partners, universities, research institutions, a very good, well spread group that we're working with in many different industries, again, ranging from governmental and military and space to looking at concrete, asphalt, and additives like that kind of on the initial end, but then ultimately working pretty heavily in the plastic space and of course in the battery space as well. At any given time, we have 10 to 15 research and development projects underway, which are further demonstrating the commercial use of our products. And then we're partnered with several highly regarded research institutes, Texas A&M, Auburn University, University of Houston, several universities in Europe, Canada, and South America as well. Again, just a quick smattering of some of the people that we're working with on a daily basis towards the development of our products. As I mentioned earlier, Elemental uses waste plastic as a feedstock. So we're able to take plastics that are typically unrecyclable or under recycled. These plastics don't need to be washed. They don't need to be particularly clean. They just need to be ground down and relatively dry. And if you look at the investment case for Elemental, certainly we're here to talk about graphene, but if you look at our process, we can take waste plastics that are in the oceans, that are in our streams, that are filling up landfills and littering our highways, take that waste plastic, grind it up, put it through our process, and create ultra high purity graphene and hydrogen, which I think is just a huge benefit to society, but also to the development of carbon nanomaterials as well. With regards to sourcing and supply, we have very deep and wide sourcing and supply relationships, and as we continue to scale, we'll further solidify those with offtake agreements. Just a couple of things I'd like to highlight about work that we've been able to conduct with third-party research institutions on our process. One just kind of on concrete, 1% inclusion of our material greatly improved the compressive strength of concrete. No surprise there. And we're working pretty heavily within that sector to further develop our product into those markets. In plastics, we've done a lot of work, not only in polyurethane and in being able to help reduce hydrolysis in that, but also have done quite a bit of work in wear testing, carbon fibers, and in other areas of the plastic space, really showing an improvement in impact resistance, wearability, flexibility, and conductivity of plastics when used with our graphene. And then last but not least, really excited about our battery work. We've done both work in batteries and also in supercapacitors, and our batteries made from our graphene achieved over 30,000 full charge and discharge cycles, and supercapacitors made with our material achieved over 110,000. Actually, it's actually 110. There's a typo on the slide, but 110,000 full charge discharge cycles. And when I speak about that, you look at that in comparison to a cell phone or a Tesla battery that may have really, 2,000 to 3,000 for full charge and discharge cycles. And the fact that our batteries made with our material were able to get 30,000 full charge and discharge cycles is really quite impressive, and has really been a highlight in many of our battery discussions, whether using graphene as all of the carbon in the battery, even just part of it to enhance the graphitic performance of the material. It's really been quite exciting. And these were full charge discharge tests. A lot of tests with graphene in batteries and other just carbons in batteries are oftentimes extrapolated on spreadsheets and not actual testing. We took the time and did the full tests, and we're really pleased with our results. A little bit more about our technology. Again, we can take between 10 and 12 tons per day of plastics in through our system here in Houston. Our feedstock, again, is plastics. The process is CO2 neutral. It's modular. It's big. It's big enough, small enough to where you can put it on the back of a regular truck or put in a shipping container. Commissioning is in process right now. We produce no waste, just carbon and hydrogen. And we can use plastics that other people just can't really recycle. Next thing that you'll see is that we probably have the lowest CapEx and OpEx in the industry. And I think about that in several ways. And I love the chart that Terrence shows. If you've ever seen the graphene hype cycle chart that I love, it talks about really kind of the hype of graphene, and really what we see is what's really held back graphene is really the ability to produce enough at scale to where it's meaningful for industry, but also be able to do it at a low enough cost to where you achieve that nice high volume and reasonable priced product. Elemental is able to do that, and I think it really sets us apart as an industry player in that we're able to produce at scale. And when I say scale, a single machine of ours can produce easily at full scale, probably up to 20,000 pounds of graphene per day, which is monumental. A quick chart just showing how we stack up in comparison to others. I think some big things that we're able to do, certainly our energy consumption because of the scale of our process is better than most. Obviously, waste plastics as a feedstock is impressive in that we're able to take a very wide variety of unprepared feedstocks. Our process is CO2 neutral. Our graphene is turbostratic, which I think is helpful, and we're a single step process. Here's how we stack up from an energy performance standpoint. Again, because of the scale of our system and the design that we've been able to come up with, we have the lowest energy use of any known technology in use today. Aside from just making graphene and hydrogen, some of the interesting things about our technology is that we can use a wide variety of feedstocks. We can take methane, we can take acetylene, we can take CO2, which is pretty interesting. But we're also patented for things like coal, propellants, munitions, other organics, and things of that nature, and can put that through our process and generate graphene and hydrogen. Obviously, with CO2, we can't make hydrogen, but in other materials we can as well. Additionally, our process is capable of producing rare earth elements. So, for instance, we can take solar panels, we could take electronic waste, printed circuit boards, what have you, put it through our process, flash off the hydrogen and the carbon in the process, but then the rare earth elements and the precious metals would sink to the bottom of our process, and we're capable of tapping that off and collecting rare earth elements and other critical materials. Again, we have a pretty comprehensive IP portfolio with worldwide protection in many different areas, really everywhere except for China, but pleased with what we've put together. Relative to the UN Sustainable Development Goals, we checked five of their, I think, 17 boxes. So really pleased with what we're able to do with our technology, not only from creating amazing carbon and hydrogen, but certainly being able to use plastic waste as a feedstock is a huge feather in our cap with regards to our technology. A little bit about the team. I serve as the company's CEO. I've been here since January of this year, but I've been consulting for the team for about 2 years. The two founders are Ron Presswood and Ian Bishop, who continue to work with me here at Elemental. And we have a diverse background, and I think it really helps us from a business perspective as well as a technology perspective. A couple of reasons why to invest in Elemental, and currently, just for everyone's information, we're looking at possibly doing a Series B round later on in the year, probably in the October timeframe, right before the holidays. But the technology, it's proven, it's scalable, it works. It's the most economical technology on the market, best in class environmental profile. I love the triple factor benefit. We remove plastic waste, we produce graphene, we also generate hydrogen. I mean, it's a triple factor benefit that it's hard not to smile when I think about it. Other opportunities for our technology, especially the rare earth element piece, I think it will be critical as we look to further domesticate battery production and as our demand for rare earth elements in the country grows as well. And the modularity of our design, the fact that we can pick these things up and really deploy them wherever we need to, really is a huge factor in our development. That's all of my prepared comments today, and happy to answer any questions.
For more information on market opportunities and to connect with experts, contact the Graphene Council at thegrathenecouncil.org.